We meet again.
Okay, I see the same group of people is here. That's good. So actually today hang on, give me 1 second. I think. Okay,
So this is
do you guys
the
hear me okay?
SIPI design kit meeting, David, just to be clear.
Okay, I'm not hearing anybody. Let's see what's wrong.
Can you hear me?
Yeah, okay, now it's working. Probably my volume was down. Sorry about that.
So this is the SIPI design kit meeting?
Yes.
It's well, it shows up as CDX.
Well, I'm
Yeah,
looking at it right. It says CDX meeting in parentheses, Chiplet SIPI design kit.
I don't see that. So I guess
That's the OCP invite.
yeah, I'm in the OCP invite. I just see open chiplet account a CDX workstream call.
I don't think you're looking at the one that came from OCP. You're looking at something that I think
A legacy one.
Yeah.
All right.
Yeah.
So is this something that you want us here for?
So I wanted to give the team a quick update. So again, right, if you remember a few weeks ago, JP joined us. We had a good progress in terms of defining some of the SIPI attributes that we want to capture, right? In terms of limits, IP limits or standard limits. JP has a conflict at this time, so he's not able to join us at this specific time. However, I'm working with him offline. Usually it's nights that he gets free. So wanted to give the team a quick update about that. I met with him. We also had a good progress, and I'm going to meet with JP one more time. And I think we will be able to basically conclude in that what are the electrical parameters we want to capture for different standards? How do we capture them and what those would look like? Once that is done, I'm meeting with him this week. So our next SIPI meeting is in 2 weeks. So
David, can you please add Mohammed to that discussion?
Yeah, sure. So my expectation is in 2 weeks' time from today, we'll have a kind of first cut spec. What are the parameters we want to capture, and what the XML would look like for that. And hopefully wrap that up topic after that, right? Everyone can review it, comment, and once we're happy with it, just go and get it out the door.
Yeah. So I don't recall how this new spec became about. I know there was a discussion quite a while ago when we wrote the original white paper that it would be nice to be able to describe
Exactly.
windows. So I guess we've officially created an initiative to define these SI and PI electrical specs.
Yes.
Which I think is good. Now, where does this fit into the overall scheme of our 3DKs? Because this is something that
this is going to be again part of the 3DK. The way it's the way it is intended to be is at a first level. There is a standard. Each standard defines requirements and limits for SIPI, right, on the TX side.
So you're talking about standard IO protocols.
Correct. Like
Okay.
you say, Bo and Poly will be able to capture this as well, right?
Right.
Because
So
right, because
this to some extent is analogous to the standardized pin names in the CDX model, right?
yes, it is in a way that yes,
Which
basic
is in the physical model. So these really, I would view this as an extension to the CDX electrical model, right?
yes,
That's
these
where
are
the
going to be yes, these are going to be extension to the electrical model
okay.
in a
So
way, right?
the E101,
Sorry.
E101, the Chip
Yes.
E101, right?
Yeah.
So
Yeah.
Michael,
And
you're on board with this? You're on you're on mute, Michael. All right. Michael, you
yeah.
there?
Yeah.
Okay.
Yeah.
That
So
that's
right.
fine. I don't think this is an initiative. I'm kind of just it's really just a continued extension to existing standard. In fact, I think the in my view the P TDKs is really an extension of the physical model because these are specific to a chiplet and it should be in the CDK in the JIT30.
Yes.
So
All
the
right, guys, I heard everything you said, and I was down just getting coffee, and I had my mute my phone. So yes, I agree with everything that you're saying.
okay.
Yeah. So that's where we are with SIPS stuff.
Do we have a list of the rules yet around the PDK
Around which?
and the PDK, the process design kit? But Tony just was mentioning there is that he said he thinks that they belong to the chiplet and therefore maybe should be part of the CDK.
No, we don't. That's going to be the next thing we work on, Michael. Right.
All right.
One thing at a time. Right.
So the
I don't want to.
the SIPI, where did they belong to? Inside the electrical portion,
Yes.
Yeah.
right? And next week, in 2 weeks' time, you'll have a list of those prior properties.
Correct. And we'll have the initial CDXML schema as well, and we'll go and publish that.
Yeah. Now, David, after we implemented the original CDK into the JEP30, the MOU states that you should download the JEP30 document and use that as your base foundation onto which you make new proposals. So when you come up with this new CDX schema, are you using the JEP30 as your base, or are you using the old OCP?
Michael, that's not my understanding. My understanding is that CDX will continue its work on the CDXML, and we will contribute the way we did the initial CDXML. We will contribute the same work to JEP30.
So I thought there was a link.
And there is a link after JEDEC publishes something. After JEDEC publishes the standard, we will make sure that CDXML complies with that standard, and we have a bidirectional link. Right, we want to keep both in. We want to have a sync points for both work streams to make sure we are compliant. But in a sense, the CDXML work is independent of JEDEC work. Right, we just we make sure that we collaborate, but there is no requirement in the MOU that we follow the exact JEP30 schema.
Okay, so I'm
We can
going
go
to
in
have and check
and
that, David. But how do you ensure that your CDXML version is in compliant with the published size version of the JEP30? Because the CDXML portion of what we integrated is already been published.
yeah, so the way it the way I understand it is that we have representation of the same data in both formats, such that we can go from one format to another if we wanted to, right? But in terms of right, so we don't create we don't
representation
have
of the data
we don't have different data in both formats, so that a user, if that they doesn't know what to do. We need to have the exact way to represent the exact same data in both formats.
All right.
Right.
Okay. So
but
that's
in terms of work, the work happens independently in both streams, right? You guys are working on the JEDEC side, which we are not part of. And CDX is an open forum where we can all work on, right? And anybody is free to contribute. But again, the intent is that we stay in tight sync in terms of representing the same data.
All right. So I think everything you're saying is valid, with some caveats there. So when you're after a JEDEC publication, right? And the belief was that you would, in my opinion, the belief was that you would take the JEP30 document and you would continue to develop on that as a platform to your heart's content using the OCP community. But whatever it is that you develop, you can consume that within your community. But as soon as you submitted that to the JEDEC website, then for their integration into the next iteration of it, that next iteration then becomes confidential until it is published. But the prior version of it and the work that modifications that you're doing to it, etc., is shareable within your OCP development community. I'm
not sure I follow exactly, but I think let's take this one offline. I don't think this is the right forum to discuss.
Okay.
All
right.
Yep.
So David,
okay.
Just a couple of questions about usage of these formats. So I think we agreed that it makes sense to embed these, I guess, channel requirements and specifications within the electrical model of the chiplet, correct?
Yes.
So in general, you've got a chiplet on either side of a channel, at least in the packaging side, and on the PCB side, it would be on a channel, but one would be on there would be two different chips on a package, or on a PCB, or in the case of a die-to-die protocol, it would be two channel between two chiplets within a package. So so when you're building a channel, how do you use this, right? You're going to run signal integrity analysis, and you've got essentially you have transceivers on either side, right? So how do we take that to define the channel requirements? Like, so maybe we have a 100 gig SerDes hooked up to a 200 gig SerDes. So the one, you're going to have much more stringent requirements on the 200 gig SerDes, but the overall channel requirements, it's the least common denominator, right? So do you reconcile that somehow? So what we want to do, I guess, with this information is when we're designing and analyzing the channel, we want to have these specifications in a machine readable format. So
Yeah.
what's the usage
So
model on how
the
that would work in the scenario
the
defined?
the channel specification will basically be the delta between the TX performance and RX performance,
And you're going to
right?
compute that, or is that computed in the design environment?
That can be derived from having the data on the TX side and having the data on the RX side. You can back calculate what are the channel requirements.
Yeah, I
For
know you
example,
can, but who's doing that? Is that a tool doing that? Is that the designer?
um,
A script?
that would be the designer, right? So it depends, right? Uh, technically, um, uh, let me give you uh, one example, right? The standard, bowl standard defines maximums, right, in terms of standard for the RX, say the clock jitter on the RX side, and it would also define the jitter on the TX side maximums, and the delta of the two will give you the maximum channel induced jitter, right? Basically, the three values are you can calculate one from the other two. In the case of a specific chiplet, right, the chiplet itself may have better values than what may have better or worse values
Right.
than what the standard has, right? So again, as a designer, I would need to take a look at the performance of both chiplets on the chiplets on both sides,
Right.
and derive what is going to be the limit on my channel, and I will design that based on the channel. Now, your question whether a person does that or a tool, I guess it could be either one, right?
Okay. Okay. All right. So I think I follow you. So there will be channel requirements that are specified by the designer, and how he does that, I guess, is up to the designer.
Correct.
And
Correct.
the information about the transceivers is embodied in the chiplet models or the chip.
Correct. Correct.
Yeah.
And again, that same information for the triplets could be used for the planning phase, as well as for the actual simulation, right? If the compliance kit needs to assume some jitter on the clock, today it might assume it based on the standard. But
Right.
if you had the specific chiplet information, you can the tool should be able to read that in from the chiplet model and use that as a jitter on the TX side, right? And compare to the jitter on the RX side, which also could be different than the standard.
Yeah, I mean, traditionally, it's you're just using an IBIS model for the transceivers, right?
Yeah. So apart from the IBIS model itself, right? Uh, uh, the the IBIS model will not have the jitter built in it, right? And the statistical simulation needs to know what that maximum is, right? So that it can exercise those worst cases. That maximum will not come from the IBIS model. That
Yeah,
will come from the standard specification or from the IP description or chiplet description.
yeah, and that noise would be added into the SPICE simulations.
All right.
Yeah. So Mohammed, you're an SIPI expert. Does this sound useful?
Yeah, Tony, I think Oh, overall, I'm just still trying to assess, like, what is the, you know, advantage for us to, how is it gonna be different chiplet versus, like, what, like, in a regular flow with, let's say, through PCB, how it's gonna be different. I'm still trying to, a little bit trying to understand that part. Because transceiver in any case is still present on, like, just the channel is different, right? Channel is smaller, maybe going through some package layers and so on, RDLs and so on, compared to going through PCB. But requirements will be very similar, right?
What we're essentially trying to do is define the channel requirements in a machine readable format. And today that's done either in a specific tool by filling out a form, or manually setting this information up in your simulation database. So that, right? I mean, yeah, that's how this works today, right?
Right, yeah.
So the idea here is, rather than having a person filling out a menu in the tool to define the channel requirements, or handwriting a spice stack, the idea is to have an EDA neutral machine readable format to describe the channel specifications. And then the different tool vendors would use that. So depending if you're using one tool versus another, you're defining those specifications once, and it doesn't matter what tool you're using. Is that something that you would value as a designer who may be using multiple tools?
Yeah, I need to think about it, because channel, the way I look at it, it's a, um, you know, are we trying to put an upper bound on the channel, basically, like, okay, this much should not be the loss here, crosstalk should not be that much, next
Right,
fixed coefficient.
right. Yeah,
So,
that's the goal, is right, that channel
yeah,
spec is creating
right,
that channel spec in the language, right, in the XML schema. So this is the spec for the channel, and then
right.
that's your spec, and then your analysis tools could just get the values of those specs and run the analysis to determine whether or not you met that or not.
I see. Yeah, I think it's like, breaking down the problem further into, like end to end, you need to, with IBIS model either side, and, have the channel, you try to look for, like, what's the margin you have in the eye diagram versus, looking just specifically for the channel, assuming, there's no imperfection on the transceiver side, either one of them, and then you just put some specification on the channel itself.
Right.
Yeah, I think,
So
yeah.
yeah. So okay. So the idea, kind of in the spirit of predictive analysis, right? So if when you're very early in your I call it architectural planning and analysis, you haven't specified a specific vendor for your SerDes or your DDR interface, right? So the idea is you can just start with the standard, right? So we would just have a generic model that has the generic specs for the protocols. Those are the call it generic or ideal transceivers, right? So that's your default, and then you could go off and actually say, well, can I design a channel in organic interposer that meets the requirements for this 250 gigahertz
Right.
PCIe Express, whatever. And if the answer is no, it's like, okay, so all right, let's look at a silicon interposer, or look at a different process. So
Right.
there's many decisions that have to be made once you have your architecture defined. So at the highest level, you're breaking your system up into different chiplets, right? Those chiplets need to be connected to the inside world and the outside world, and they're going to be using these high-speed protocols, DDR, UCI Express, PCIe, Ethernet, whatever. So you could define at a high level all those interfaces, and you're going to specify the speed of your systems, right? So, and then you have to decide what technology are you going to use for each of the chiplets, what packaging technology are you going to use to hook all this together, and then eventually you're going to have to pick out what IP vendor are you using for the IP that's in those chiplets. If it's an existing chiplet, it's predefined, that's what it is. But if you're building a new design, you're at some point the first thing you have to do is decide what ASIC technology is it going to use, and then what IP is out there. And you could look at different vendors, and some vendors they will specify their performance, whether or not they meet or exceed the actual specifications. And the idea is that those specific IP requirements would be put into the port model for the chiplet. So if you have a 5 from Rambus or from Blue Cheetah in your chiplet, you would get the information from that data sheet and put it into the port model, into the electrical port model, right? So then you could actually run the analysis, and the port model actually includes the IBIS model as well. So you would have kind of the specification requirements, which would be used to again define what the channel requirements are, and then it's actually used to set up to run the simulations.
Yeah, I think it makes sense now, right?
Yeah.
Basically, we have designer has so many flavors available for those channel, through organic interposer, silicon interposer, putting some specs on that, it definitely will help, close that design cycle quickly. They can, know, okay, is this gonna be a good option for or to further proceed or not? Yeah, makes sense. Yeah.
So we could code up an eye diagram as an XML code, right? And then the different tools would just say, okay, how do we map that into our SI tool? Initial scripting, and the long-term goal, if all tool vendors agree on these standards, they just support it natively, right?
Yeah.
Okay.
Okay. Anything else for today, guys?
So again, David, you're 2 weeks. You said you
Yep.
think you're gonna have a cut of the spec. Is this posted someplace?
I'm sorry. No, it's not. We'll
You'll put a link in the next meeting invite where this is posted.
Yeah. Right now, I'm using the meeting minutes to kind of go through the stuff that we were discussing right there some time ago on the 29th August. We kind of had an initial discussion, went to a bunch of parameters, and we'll just clean that up and make it into a spec.
Mm-hmm. So has John contribute to this, any of these discussions? John Chaka?
No, I've been working with JP on this one.
Okay. Okay, very good.
All right. All right. Thank you. We'll talk to you.
David, if you can hang on.
Hang on. I quick announcement. Next week is OCP Global Summit, so there will be no CDX meeting. I'll cancel it.
Okay. And your
Go ahead, Michael.
Are you doing any papers or presentations or demos?
Just high level talk on 3DK. Some of the work that we've been doing, just high level. Present to the. We have a few minutes only to present, so
Okay.
inform the entire community about what's going on.
Okay.
All right. So David, I invited you to tomorrow's meeting with JEDIC. We're going to be covering a lot of new units and properties that Infineon wants to get added. But I'm
Okay.
also going to take the opportunity to introduce the concepts of design rule kits. Now, I'm not planning to go into the detail of the MDKs or any of the design rule kits. I'm just going to talk about the concepts of why it is that we're bringing it in there to the part model. So we're keeping it keeping that at a high level. And then afterwards we can go into the more detail. I still some issues I have to fix up on the MDK that I need to review with Andrew and Bill Harden, but I just ran out of time this week to do that.
Okay. Yeah, it's 6 a.m. is testing me. It's 6 a.m. for me.
But I have guys from Japan logging in and Japan and India, so it makes it very hard to pick a time that suits everybody, you know.
Yeah, understood. Yeah, I'll try to. You guys don't record those meetings, do you?
We're not allowed to. Can't record the meetings.
Okay. All right.
And unfortunately, I cannot share with the OCP. I can share with you personally, because you're one of the names that's on the JEDIC group. I can share with you personally the JEP 30 minutes of the meeting afterwards, but I cannot share. I cannot
understand.
Share the final documents. You know.
Yeah. Yes. Yes. It's understood. No problem. I'll try to join.
Okay. All right.
All right.
Take care.
Okay. Talk to you guys in 2 weeks then.
Okay. Bye.
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 Nathaniel, are you still here?
Yeah.
You're looks like you're out on your for the next 2.5 hours. You're back again afterwards, is that?
Yes.
Okay, will you sync up with me when you get back?
Yeah, sounds good.
All right. Thanks. Bye, guys.
Bye.